Everybody seems to be popping in right on time. I'll start with a brief introduction of myself in the program. Thank you everybody for joining us this evening. I'm Amanda Liberty with the Rangeley Lakes Heritage Trust. John Meader is here again. He has been amazing this winter, working with us when the weather hasn't and bringing us this virtual program. So I can't thank you enough, John, for being here as well. So with that, I'll hand it off to you.
All right. Well, good evening, everyone. And my name is John Meader. I'm the director of Northern Stars Planetarium, which is an inflatable star theater. And I travel to primarily elementary and middle schools all over the state of Maine, teaching astronomy to schools. I sat on these glasses, so they're all crooked now, to elementary and middle school kids all over Maine, and occasionally libraries and rec departments. And, anyone who wants to hire me, I'm self-employed. But this evening, I'm going to give you a presentation on the spring sky. Now, some of you may have joined us before. We've been doing this monthly for the last 2 or 3 months, where in the last couple of months, in January and February, we concentrated on the winter sky. And we're going to see a little bit of that today, but we're going to really concentrate on what we have ahead in the spring. So I like to start this before sunsets. We've backed up a little bit here. This is just a little bit before the sun went down. And as you probably know, last Sunday was the equinox, and that's the first day of spring. It's the only one of 2 days in the year where the sun sets exactly in the west. The 2 days are the spring equinox, the first day of spring, and the first day of fall, the autumnal equinox. In the wintertime, the sun sets down south of west. Back in January, it was setting between southwest and west-southwest, kind of right over in here. Last Sunday, it set exactly in the west. And tonight, since we're like 5 days past the equinox, it's going to set a little north of west. And if you came back in a month, it'd be even further north, all the way up in here somewhere by the 1st of June when you get to the solstice. And that's when it starts coming back. So we're going to speed up time and see where the sun goes down. If you notice, there's a W here for west. So let's get that sun going down. We'll just speed up time a little bit. There we go. Ooh, we got it going pretty quick. You see, it's just a little bit north of west. We're going to let it go down and let the stars come out. We're going to go a little later tonight than we have been doing this in the past, because I want to concentrate on spring skies. Let's stop about there. This is a little after 10 o'clock. I really want to stop the time, so let's shut it right off. And the reason I want to do this is because spring is brand new. It just started last week. And a lot of the stars and constellations are the same ones that you would see in the wintertime. We can still see, for example, Orion the Hunter right here, a very famous wintertime constellation of the Great Hunter. The 3 stars in a row mark his belt. He's got a leg here and a leg there. I usually don't like drawing a line between his feet because I think it can make him fall down, but they do in this program. And as you'll see here, I don't always agree with the way they draw the constellations. I draw my own way that I see them better. You can too. Above his belt, he's got a body. I draw a line between these stars for his shoulders and a little line up for his head right here. An arm with a club and an arm over here with a shield. Now, sometimes it's drawn with a shield. Sometimes that's drawn as a bow for a bow and arrow. And sometimes it's drawn as the skin of a lion. All depends which story you're referencing. I think if we put on the fancy drawing here, you'll see they draw him with the lion skin. I like the shield better myself because I'm not that familiar with the lion story. I talk about many other stories around Orion. But that's a wintertime constellation, which actually stays in the sky till almost the end of April before it disappears for the whole summer. And then it'll reappear around between Thanksgiving and Christmas as far as the evening sky is concerned. And right now at 10 o'clock tonight, you can see it's right over in the west. And by midnight, it's gone below the horizon. Orion is standing next to his dog, or his dog is standing next to him. This is Canis Major. The bright star, the one I clicked there, is Sirius, which is the brightest star in the entire night sky. It's also known as the dog star. And you see here it's drawn as the dog's collar with a neck and a little triangular shaped head, a body here, a couple front legs and a couple back legs, and a tail right here. Orion has 2 dogs. So this is Canis Major, which means the big dog. Canis Minor, the little dog, takes a little more imagination because you go from Sirius past the dog's head up to the next bright star, a star named Procyon, and that's the puppy dog's nose or tail, depending which way you want to point him. I usually think of it as his nose, but in this program, they draw it as his tail. This star, if that's his nose, this is his tail, or if that's his tail, that's his nose, because all there is just those two stars. Doesn't look much like a dog, does it? Kids like to call it the hot dog because it looks more like a hot dog than a real dog, obviously. But as you can see, they draw it with the two dogs facing the same way. You see it drawn both ways. One thing you learn here, is, if you haven't learned this already, is if you go buy 2 or 3 books on constellations, or to get a couple different apps for your computer or your phone or your tablet, you'll find that they always use the same stars, but they will draw the pictures differently. There's no right or wrong way to draw them. I tend to like the line drawings better than the ghostly pictures, even though the ghostly ones are prettier, because when you go outside, you're never going to see these ghostly dogs floating in the sky. At best, you can use your imagination to make a dot-to-dot picture. So I tend to lean that way. But as far as scientists are concerned, they just draw squares and polygons around a group of stars, and they say everything within this polygon is part of Orion, and you can draw it any way you want. So that's why they draw it one way here, and I draw it a different way. And it's the same with all of these. Well, these are 3 wintertime constellations, which you can still see right now. But as I said, I don't really want to concentrate on winter. It's spring. And if we look over in the east, we can see some springtime constellations. And you can see a few of them earlier in the evening. But if you wait till 10:30 or 11, you can see the stars that you will see right after dark by the end of April. So in early May, which is kind of the heart of springtime. Now, this guy I have set right here, right now, is kind of set for not where you are if you're up in the Rangeley area. It's kind of set for the way the sky might look if you were in a town the size of, let's say, Waterville or Skowhegan or Bethel or Farmington, or some small, reasonably sized main town. Maybe not quite as small as Rangeley or one of the towns up that way. So we've got a little bit of light pollution here, washing out some stars. If you get in a really dark spot, like many of the regions where you are up in Rangeley, then the sky looks a little bit better, more like this. I can't fade it, unfortunately. It's either on or off, but this gives you a much brighter sky. The stars that were there are brighter, and we see a lot more fainter stars. This is why we keep talking about dark skies, because if you're in a dark sky spot, you can see not just twice as many stars, maybe 3 to 4 times as many stars, and the sky becomes much more beautiful to look at. Some people say it makes it harder to see the constellations because there are so many more stars, but generally most of the constellations are made of the brighter stars. Now, in this spring sky, we use one constellation to find our way around to find all the others, and we're going to start with a really easy one in the springtime, and it's right straight up in the spring. It's one that you probably all know. It's called the Big Dipper. The Big Dipper has 3 stars for curved handle right here, and then 4 stars for the pot or the bowl, like that. So most people can go out at night, and if you don't know any constellations, you can look around and find the Big Dipper, right? Well, if you found the Big Dipper and you think, well, at least I know one constellation, not to burst your bubble, but technically that's not a constellation. That's what we call an asterism, which is a group of stars that's easy to recognize, but not quite a constellation. The Big Dipper is part of a larger constellation called Ursa Major, which means the Great Bear. And we have to add a few stars to turn it into a bear. The handle of the dipper becomes the bear's long tail, because you all know bears have long tails, right? Wrong. Well, in the sky, that one does. And there are many stories explaining how his tail got to be long, but we're going to save that for another day. The dipper, you come out to these 2 stars, and that's the bear's long, skinny body with a nose out in front, a couple front legs here and a couple back legs here. Oftentimes you'll see it in many books. This is drawn as one back leg, and the other one comes down straight to this pair of stars for the other front leg, whereas the back legs are always drawn together. These 3 groups of doubles, this one, and this one, are known as the 3 leaps of the gazelle from African lore. I always like that. It looks like 3 footprints, like he leapt across the sky. But they're actually technically part of Ursa Major, the Great Bear. Now, the Big Dipper, and that's all I really need you to find. If you can't see the bear, but you can find the dipper, that's fine, because that's going to help us learn a whole bunch of other cool stuff. Now, the way we do this, the first thing most people want to find is the Little Dipper. To do that, you go to the back 2 stars, the Big Dipper's pot. Those are called the pointer stars because they point at something. Their names are Merrick and Doobie, And you draw a line from Eric to Doobie, and you doobie right across the sky, and it'll point you to this bright star. It's not super bright, but it's the brightest one in the area. You won't miss it. And that's probably, believe it or not, the most famous star in the entire night sky. That's Polaris, the North Star. It's not famous for being bright. It's famous because of where it is. If you look right at it and then look right straight down, draw a line, the closest line to the ground from Polaris will always take you to due north. It's directly above the Earth's North Pole. So if you're standing at the North Pole, it would be right straight above your head. But we're in Maine, and we're at about 45 degrees latitude. So it turns out the height of the North Star above the North horizon is always equal to your latitude. So if you measure this angle from here to here, that would be roughly 44, 45 degrees, depending on where you are in the state of Maine. If you're at the North Pole, it'd be straight up, and you measure the angle from straight up to the horizon, that's 90 degrees. That's the latitude of the North Pole. If you're on the equator, your latitude is 0, and the North Star would be right on the horizon. So its height tells you your latitude, which is kind of cool. It also marks the end of the handle of the much fainter Little Dipper. The Little Dipper bends like this. The North Star is the brightest star, and then the handle bends down around, and this little square marks the pot or the bowl. It always hangs back towards the Big Dipper, like it's a ladle you're going to scoop macaroni and cheese out of the Big Dipper with, if you're going to cook something with it on the stove. So that's the first thing most people find by using the Big Dipper. You find the North Star with the pointer stars, and you find the Little Dipper. But now I want to go back to that Big Dipper for a minute, because that can be interesting all by itself. People find the Big Dipper, then they want to go find other stuff. Well, you could spend the whole night, if you had a telescope, just examining around the Big Dipper and find some really cool things. Let me show you a couple. Right underneath the pot, right about in here. Let's center it so we can get into it. You're going to find something very, very cool. And what I want you to look for is a spot that looks a little bluish green, kind of teal colored. Not right, I didn't zap right on, I just grabbed a star nearby. And it's right beside it. You can kind of see it there. This thing right here. It's called the Owl Nebula, because it kind of looks like the round face of an owl with the two dark eyes here. Well, nebulas are big clouds of gas floating in space, and they're different kinds. There's a type called a hydrogen 2 gas cloud, which is a place where hydrogen, that's what it's made of, is collapsing to form stars. That's not what this one is. This one is a dead star. This is a star that when it was, younger and still shining, it was a star very similar to our sun. Now, stars the size of our sun will never explode. They won't go supernova. For a star to explode, it's got to start off being at least 8 to 10 times more massive than the sun. So this was originally a star very similar to our sun. And what stars do is they turn hydrogen into helium. And when they run out of all the fuel, they go through a whole series of iterations, which we don't really have time to get into today. They run out of fuel, and then they collapse on themselves. And there's one last fusion reaction that doesn't happen in the core anymore. It happens about halfway out, and it pushes the outer layers away into space. And those layers expand away and form this big shell of glowing gas. And these are called planetary nebulas. They have nothing to do with planets, but after Uranus was discovered in 1781, there was a whole bunch of astronomers got really excited. They want to find a planet too. And in the telescopes back then, these were the one things in the sky that had a round size like a planet does. And so they wondered, could these be planets? Well, we found they're not. They're nebulosities of stars that have died. They didn't know that then, but they got named planetary nebulas. This is a really pretty one. So that's how our sun will die one day. It'll create something that looks just like that. And that's right under the pot of the Big Dipper. I want to show you one more thing before we leave the Big Dipper. So that was a star that died. And that one was called the Owl Nebula. And the Owl Nebula, I'm trying to see here where I thought I had a note here how far away it is. I'll find it here at some point. It's quite a ways away, but some of those are closer and some are further away. They're pretty small objects. The next thing I'd like to show you is much further away, but it's a much bigger object. It's right off the end of the handle, right about in here. So let's zoom in there. We need it to center again. And again, it's not right where I clicked. I just clicked on a nearby star. But just to the left here, you can see this interesting object. This is what I want you to look at. This is called the Whirlpool Galaxy. Its designation is M51. And the Whirlpool Galaxy, M stands for Messier. Charles Messier was an astronomer who was interested in comets. And he started cataloging things that weren't comets, but kind of looked like a comet in his early telescopes, fuzzy spots in the sky. And he cataloged 109 of them. Well, this is the 51st one he cataloged. We now know it's a galaxy, very much like our own Milky Way. We live in a galaxy that's a spiral too, and it has spiral arms, just like the Whirlpool Galaxy has spiral arms. The sun is one of the stars. If this were the Milky Way, the sun would be about out in here somewhere, about halfway from the center to the outside edge. So imagine the sun right about in here. Well, we have the Whirlpool Galaxy. Then we have this fuzzy spot here. That's another galaxy that it's a satellite galaxy. They think it slowly is orbiting around it, but it's also receding away. They think that about 70 million years ago, these two galaxies collided with each other. We see examples all over the sky where galaxies occasionally collide. And when they do, they kind of stir things up. I don't know if you can see it here or not, but there's a lot of little pink spots all over this galaxy. Those are those hydrogen nebulas, like I talked about, where stars are forming. The hydrogen gas glows with a pink color when young stars give off lots of ultraviolet light, and they excite the hydrogen gas and make it glow in that pink reddish light. So we see lots of little pink spots all over this galaxy, which means there's a lot of young star formations. And they think that happens when galaxies collide with each other because it kind of stirs the pot of all the gas that's floating around, stirs it up, and it starts clumping and forming star formations. So we see this beautiful galaxy kind of straight down from above, and we see this one that's receding away into the distance while it also is kind of orbiting it. And it's one of my favorites, called the Whirlpool, and it's right off the tip of the Big Dipper. Well, let's leave the Big Dipper. We found a couple of interesting things there to whet your appetite. Right underneath it, you notice that when I clicked on that, these two stars lit up. They're called the hunting dogs. This is not one dog. This is a pair of dogs. So each star is a dog. And they're the hunting dogs of Boötes, the bear chaser. Well, we know the Big Dipper is the Great Bear. Well, look at the handle. You see how the handle of the dipper, let's bring it so you can see the whole thing, how the handle arcs or curves. Well, if you follow that arc down and keep going, it'll point you down to this very bright star, which is conveniently named Arcturus. So you follow the arc to Arcturus. Arcturus is the fourth brightest star in the entire night sky. Now, the first one was Sirius, which we saw in the big dog earlier on. This is the fourth brightest, and it's the brightest one north of the equator. Sirius is south of the celestial equator. So it's a very bright star, and it's part of the constellation of Boötes. And this is Boötes. Now, Boötes was a herdsman and a bear chaser. Well, the Great Bear is the Big Dipper, and he's trying to protect his herd of sheep from the Great Bear, so gets both names. Now, I can't really make that look like a man. The ghostly images, they could draw a picture of a man over it, but I don't see how you really take those stars and turn it into a human being of any kind. So I don't try to. Just the way we look at the Great Bear, we just call it the Big Dipper. I like to turn Boötes, the bear chaser, into a different asterism. And there's two common ones. The most common one is probably the kite. You see, it kind of looks like a kite with a kite's tail coming off the bottom. Maybe this is the tail and this is the string going down to whoever's flying the kite. There's another one that I like even better. I call it the ice cream cone, and many people do. This is the point. Get a side here and a side here, and you draw a line between those two stars. So this is the cone. And of course, this up here is the scoop of ice cream. I think it's heavenly hash, but don't quote me on that. Now, you might say, well, that looks good, but how do you account for these lines? Well, remember, you don't have to. You can draw the lines anywhere you want, and you can ignore the ones you don't like. So long as you're within the boundaries, and here are the boundaries of Boötes. So you can use any of these stars if you want to. So I just use these to make the ice cream cone. Now, a lot of kids, when I show this to them in the planetarium, they notice that right underneath that ice cream cone, if we zoom in, you can see it a little better. There's a nice little half circle of stars right here. And they show up even better outdoors than they do here. They kind of blend in here a little bit. This is another constellation called Corona Borealis, which simply means the northern crown. Kids tell me they think it looks like the second scoop of ice cream that just fell off the top. If you ever had that happen, I have. Yeah, we had one big discussion one day with a bunch of third graders about this, and someone made the comment that maybe it's the second scoop of ice cream. And one little boy spoke up. He said, "No, no, 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 no." He says, "That's the smile of the person getting the ice cream cone." Well, that's third grade, and they have good imaginations. So you can think of it any way you want, but it is called the Northern Crown. And the key is don't just call it the crown, because if there's a Northern Crown, that also implies that there might be a Southern Crown, which there is, which you see in July and August. It's very low on the southern horizon, but there's another half circle like this down there. And that's the Southern Crown, Corona Australis. And then we have Cassiopeia the Queen, which looks like a W in the stars. I'll show you that in a few minutes. It's on the other side of the sky. And that's usually drawn as a queen sitting on a throne, though kids tell me it doesn't look like a lady sitting in a chair. It looks like a letter W. But they do agree that that letter W kind of looks like a crown, like a king or a queen might wear, a three-pointed crown. So you got to keep your crown straight. Now, Corona Borealis, the brightest star is this one, and that star's name is Gemma. So think about crowns and tiaras, because to me, this looks like a tiara, like a princess might wear. And that would be the brightest star in the tiara or in the crown. Now, the star I find interesting is, I don't know if you can see it or not, it's just barely visible. If I zoom in enough, you'll see it. It's this one inside the crown. That star's name is Arcturus. R is its designation, and Corvus stands for Corona Borealis. Now, why do I like that star? Well, it's right on the visibility level. If you're in Skowhegan or in Waterville or in Bangor or Portland, you're not going to see it. If you're in a dark spot like you are in Rangeley, on a clear night, you can see Arcturus most of the time. About once every 4 or 5 years, it simply disappears. It dims down to 15th magnitude. And that's like 1,000 times dimmer than we can see with our eyes. So even with most backyard telescopes, it'll disappear. So you can't even see with those backyard telescopes. And it'll stay dimmed for a month or two. Then it brightens back up again. So this is a star that periodically just disappears with no regular basis at all. I think it's an old star with a lot of carbon in it, and that it like burps out carbon and makes a big dust cloud that obscures its light. That's one of the theories. So whenever I look at Corona Borealis, I always look to see if I can see Arcturus. And to be honest with you, I've never seen it disappear. I keep waiting for the night where I look up and it's not there, when it should be, because it's a clear night. So now let's back off a little bit. We found Ursa Major, the Great Bear or the Big Dipper. We found Ursa Minor, the Little Dipper or the Little Bear. We arced to Arcturus and found Boetes in the Northern Crown. This one's the head of a serpent, which is mostly below the horizon. So we're going to ignore that because you probably wouldn't see it anyway at this time of year. So we arc to Arcturus. And if we keep on going, we can speed on to Spica. So you arc to Arcturus and speed to Spica. And Spica is in the constellation of Virgo the Maiden. Now, I don't like the way they draw Virgo at all. So you're going to have to put up with it. Spica is supposed to be a sheaf of wheat. Now, when you teach kids and say, she's holding a sheaf of wheat, they're like, what is that? You know, a bunch of grass, I tell them. She's holding grass? They don't get that. And one little girl one day, I was trying to explain a sheaf of wheat. She said, I think it looks like a diamond ring. Maybe she just got engaged. And that made me laugh. And I thought, that's perfect. It does look more like a diamond ring. So let's call that her diamond ring. Now, I'm going to show you the lines I use. I draw a line from here. This is her hand. This is an arm right there. This is her shoulder. Her other arm comes up here. And then I draw a line between these two stars for a stick body, and I get rid of this one over here. This is her head, and I get rid of the line above her head. Come back down her neck to her shoulders, then down her body, and she's got a leg here, and draw a line over like this and a leg here. And the rest of the lines we just erase and ignore them. And it makes a nice stick person. And at least it looks like a stick person, which we all recognize. To me, this doesn't look like anything. But that is Virgo the Maiden and the bright star Spica. And Spica is the 16th brightest star in the sky. It's fairly bright, but there are a bunch of stars between this one and this one in brightness if you scan the entire sky. Now, if you, I want to back off here. If you arc to Arcturus and speed to Spica and keep on going, you'll curve on to Corvus the Crow. And what Corvus is you see this little square. That's the constellation of the Crow. I'm going to zoom in so we can see it a little bit better. So here's Spica and here's the Crow. The way I see the Crow is these two stars represent his beak. He's flying, he's whether it's a sheaf of wheat, which you'd like because you might want to eat that grain, or it's a diamond ring because crows like shiny things. He is attracted to that ring. So he's facing that way. His back is arched like this. So he's going to arch back. His wing is on the downbeat. That's the wing. Come back down his back, and he's got a tail right there. So we got a head up here, an arch back, and a tail down here, and a wing on the downbeat. He's flying up and going to go snatch that ring right off her hand, or grab the sheaf of wheat if you want to be traditional. Now, they don't draw him that way at all. They do kind of draw this picture. I mean, you could draw this as a wing, but they imagine him flying the totally opposite way, like he's scared of her. And I think he'd be just the opposite. I've spent some time around crows, and they can be pretty bold, and they're not scared away by a lady with a bunch of wheat in her hand. So that's Corvus the Crow. So we've got kind of a circle going here. Let's back off. Arc to Arcturus, speed to Spica, and curve this. Well, if we keep coming up around right up through here, we're going to find a long constellation called Hydra the Serpent. So this is the Hydra. Now, in mythology, the Hydra was a creature that Hercules fought. It had multitudes of heads, and Hercules had to go and chop them all off with his sword. And he ends up with one head that Hercules can't kill because the Hydra's final head is immortal. And this is the head up here. And the body just comes down a long string of stars that goes right across the southern sky here. The Hydra is the longest constellation in the entire sky. So all these kind of make a big circle around the sky. Leading up, keep going up this, we come to the Gemini Twins, two stick people. Their names are Pollux and Castor. This is Pollux's head. Let's come in close so we can see them a little bit better. He's got a neck and a stick body, kind of like I drew Virgo, but these two actually, they draw them as stick people. Legs here, an arm here, and an arm he's holding hands with his brother. I think they're fraternal twins because you can see they're not identical. This is his brother, Castor. He's got a longer neck and a longer body and two shorter legs, and an arm out here, and he's holding hands with his brother too. So those are the Gemini Twins. Now, these constellations make a giant circle all the way around the spring sky. The Big Dipper, Ursa Major, arc to Arcturus, we find Bootes in the Northern Crown. Speed onto Spica, and we find Virgo the Maiden. Curve onto Corvus, and we find the Crow. And then we follow this line of stars up, and we find Hydra the Serpent. And these headed towards the Gemini Twins. And they're circling my ultimately favorite constellation of springtime. It's right in the middle, and it's called Leo the Lion. To see Leo, look for a group of stars that's shaped like a backwards question mark. It starts right here, and it curves around and comes down with a dot right there. It makes a nice question mark shape. The only problem is it's facing the wrong way. Question marks go the other way. So this is the backwards question mark. Now, the key is we have to turn a backwards question mark into a lion. Well, we do that by adding a few stars. So let's put some lines on this lion like this. There are a couple ways to draw his head. Now, the way most commonly you see is this curve is the lion's mane. That's almost always drawn as his mane. Some people pretend to continue the circle around and put his face on this side, which you kind of have to pretend. And some people say this whole thing is his neck with his mane. And then you take this square and make a head up here with his nose up in the air, like he's sniffing the air. So that could be the lion's head. You can draw it either way. They're all part of Leo, remember. So this is his mane. Or you could just, if you want to simplify it, put his face over here. We come back to these stars and down and back to Regulus, which is the brightest star in Leo, which is often referred to as his heart. And that's the lion's body, his back on top and his belly on the bottom. We've got a front leg here and a front leg there. They don't draw the lines in, but I will. So one front leg and another front leg. Come back his belly. There's a back leg here and a back leg there. And a tail coming down like this to a star named Denobula. Denobula means tail. So there you have Leo the lion. We put a nice drawing on him, and you kind of envision that lion maybe a little bit better. But again, when you go outdoors, there aren't going to be any ghostly lions floating in the sky, just a bunch of stars, and you have to use your imagination to connect the dots and make the pictures. Now, when you look at these stars, there are so many stars in the sky, and some of them have secrets. This star right here is called Algeba, and that's a really fun one to look at with a telescope because it looks like one star, and with a telescope, it'll, with a pair of binoculars, it'll still look like one star. But if you have a telescope and you zoom in on Algeba, what you will find is that it's actually two stars. It's called a binary star. Now, that's not uncommon. Half the stars in the sky are actually double stars. You know how the sun has a bunch of planets going around it. Some stars, instead of having planets, they have another star going around them. If one star is bigger than the other, then the small one will go around the big one. If they're the same size, they go around each other like two people dancing. And so half the stars are binaries. They're not all doubles, though. Some stars have 2 or 3 stars. There's one in the Big Dipper that has 7 stars. That's a complicated relationship right there. The nice thing about Algeba is most stars do look white to our eyes, but Algeba through the telescope you'll see has 2 different colors. The larger one will look kind of orange, and the other one will have a bluish tinge to it. Stars do come in different colors. The colors tell us their temperatures. The orange star here might have a temperature of maybe 7,000 degrees Fahrenheit. Pretty hot. Blue stars, though, can be 20 to 30,000 degrees. Blue is much hotter color. Think about a gas grill. You want a blue flame, not a yellow flame, because blue flames are hotter than yellow flames. Colors tell us temperatures. And this is one where you can really see the color when you look with the telescope. You won't see it with your eyes. It'll just look like a white star. Most stars do have colors. It's just the part of our eyes that sees faint light is colorblind. So that part of our eyes sees black and white. So stars look like mostly like they're white. Some of the bright stars will give away their color, but to see the color, you need to take a photograph of them or look at them perhaps with a telescope. Sometimes you can see the color. Now, there's a couple things here I want to show you. Right underneath his hind end, right by his back leg, right about in here, is a really cool place to look with a telescope, because we have 3 galaxies that'll appear in the same field of view. It's called the Leo Triplet. This one's called M65. Remember the Messier catalog. This is M66. And this one up here is, let me get the number. It's not an M number. This one is NGC 3628, otherwise known as the Hamburger Galaxy. So these 3 galaxies are all in one tight spot. And they're really pretty easy to find with just a small telescope. You probably won't see them with binoculars, but you don't need to have a giant telescope to see them either. They're pretty easy to find, and they're right underneath Leo's hind leg. Now, remember when I showed you the Whirlpool Galaxy, we had all those little pink patches where I said stars were forming. If we look at M65 up close and zoom in, this one is a galaxy too. It's a spiral, but we're not looking straight down from the top. These spiral galaxies are round like a Frisbee is round. They're round, but they're pretty flat. And so the Whirlpool, we're looking straight down from the top. Here, we're kind of looking at about not quite a 45-degree angle, maybe a 60-degree angle or something, kind of at a steep angle. If you could fly way over here to the right and look down, it would look like a spiral like we saw with the Whirlpool. Interesting, though, there's almost no pink patches here. There are no hydrogen-2 gas clouds, so there's very little star formation going on. Now, remember I said that often happens after galaxies interact, because it kind of stirs the things up, makes them interact, and makes stars start forming. Well, look down at M66, right down here. This one has a lot of pink patches. And this is a barred spiral. You can see there's got a spiral arm here and a spiral arm there, and there's kind of a bar in between the two. And we often see these with galaxies that we think it may form when 2 galaxies interact. Not always, but sometimes they interact and it pulls things apart, stretches things out, and it can create this bar. And it stirs things up and creates all those hydrogen gas clouds, which come across as pink, where stars are forming. So this galaxy interacted with someone. Clearly not with the one off to the right here, because this one doesn't have it. If they'd interacted, they'd both have some pink. This one doesn't have any. So they think it probably interacted with a third one, the Hamburger Galaxy. This one got its name because someone thought it looked like a hamburger edge on. You got a bun on top and the bun on the bottom, and the dark cloud through the middle is, I guess, the burger. Well, it's not as clear to see here, but with large telescopes, larger than took this picture, you can see a number of pink spots all through it. And it does seem pretty distorted. A lot of these edge-on don't have all this haze around them. So they think the Hamburger galaxy and M65 once interacted like the Whirlpool and its companion did, creating starbursts and distorting the galaxies pretty distinctly, as you can see here. Well, I want to show you one more galaxy. And it's in a little tiny constellation just behind Leo's tail. It's called Berenices' Hair. So this is the constellation of, no, that's not it. I hit the wrong one. This is the constellation of Coma Berenices, which means Berenices' hair. So Berenices in mythology was this woman with beautiful long locks of hair, and her husband went off to war, and she was afraid she was going to lose him to the battle. And she prayed to the gods, the Roman gods, that if they would spare him his life, she would donate her hair to the gods, and everyone admired her hair. Well, her husband came back, and so she cut off her hair, and the gods took it and put it in the sky. So this is supposedly her body, and all these stars here are her beautiful locks of hair. And I'm not sure what this is. Maybe she's like lying on a couch and her legs hanging down. I'm not sure what that's supposed to be, but I usually don't even draw this line. I draw this as her lying down like on a bed or on the couch, and her hair, long locks of hair, are hanging down from her head. So this group of stars is what we call an open cluster of stars. And this is one of the closest ones to us. It's 250 light years away. And that's relatively close by. Whereas if you consider those galaxies we just looked at in the Leo Triplet, those galaxies are 35 million light years away. That's a lot further away. So these are within our own galaxy. But this region of the sky is filled with galaxies. I want to show you one that's hidden right near this cluster. It's right in this region. And it's actually right here. So let's center it here. I clicked right beside it. And you talk about an edge-on galaxy. Look at this one. Remember, this is a spiral galaxy like what we've looked at. But now we're not looking down from the top. We're looking exactly edge-on. So if you could fly off to the side and look this way, it'd look like the Whirlpool Galaxy, or at an angle, it might look like M65 or 66 like we saw. But here, this one's edge-on, kind of like the Hamburger Galaxy. But this one isn't quite as distorted as that one. Look how thin it is. And almost all galaxies have a bulge in the middle like that. They're not sure whether sometimes that might be partly because there might be a bar to it. But we do know most of these galaxies have giant black holes equal to 1 to 2 million suns. And they're always right in the dead center. So that could be in there too. But I think this one's very cool. This one is called the Needle Galaxy. Pretty good name for it. NGC 4565. It's 42 million light years away. So it's a little bit further than those other two by 7 million light years, which is a hefty distance. And this one is bigger than our own galaxy, but it's a long, long ways away. Now, if you look, you can see this is actually another distant galaxy. This is a distant galaxy. This whole region of the sky is filled with thousands of galaxies, but most of them are so far away, they just look like smudges, even in big telescopes. Whereas this one is significantly brighter and really interesting to look at. All right, so we've kind of covered the spring sky here. Let's just review that. I'm going to move on to something else. Remember that needle galaxy, that edge-on thing. So I'm going to show you another one in a minute that's much, much bigger, much closer. So let's just review before we do that. Here we have Ursa Major, the Great Bear, or the Big Dipper, as we call it. We follow the pointer stars, and they point us to Polaris, the North Star, which is the end of the handle of the Little Dipper, or Ursa Minor, the Little Bear. So we can see the Big Dipper, or the Big Bear, and the Little Dipper, which is the same thing as the Little Bear. We see the hunting dogs, which we mentioned earlier, under the curve of the Big Dipper's handle, and Coma Berenices, Berenices' hair, and of course, Leo the lion. Now, there is a secret way to find Leo. If you go outside and you want to find that lion, just find the Big Dipper first. And once you find the Big Dipper, use that imagination of yours and pretend to grab the dipper by the handle, take that pot and bang it down, and you'll hit Leo right smack in the back of the head. Easy way to find Leo the lion. Well, once you found Leo and the Big Dipper and the Little Dipper, arc to Arcturus, And Arcturus is in the constellation of Boötes, the bear chaser, or the ice cream cone, or the kite, however you like to see it. Right behind that, you find Corona Borealis. Arc to Arcturus is speed to Spica, and that's in Virgo the Mitten. Arc to Arcturus, speed to Spica, then curve onto Corvus the Crow, and then follow this line of stars that climbs back up across the sky, and that's Hydra the Serpent, or the snake, which leads you towards the Gemini Twins, which surrounds the sky, brings you right back towards the Big Dipper. Now, there's a couple more things here I want to show you real quick. I forgot to show you one that I really like. And this one is a different kind of cluster. We talked about this cluster that makes up Berenices' hair. That's an open cluster. And there are open clusters all over the sky. There's a really good one right in front of Leo. It's right here. And it's in the constellation of Cancer the Crab, which is almost invisible. But this cluster is easy to see. This one's called the Beehive Cluster. And there are about 300 to 400 stars in the Beehive Cluster. And it kind of looks like a hive of bees. It's very beautiful. And the nice thing about the beehive is the best way to see it is with a pair of binoculars. If you look at a telescope, you can't see the whole thing because telescopes look at a small part of the sky, and this is too big. Binoculars look at a larger part of the sky, and you can see the entire beehive in one view. Well, that's an open cluster. These are young stars, just like in Berenices' hair, which is a closer one. This one's the Beehive Cluster, which is a little bit farther away than the other one. The Beehive Cluster is, I think I have the distance here. Let me just check it real quick. Yeah, this one's about 575 light years away, which is twice as far away as Berenices' hair, but not nearly as far as those galaxies and things we saw. And the stars in this are young. Now they're 600 to 700 million years old. That sounds pretty old, doesn't it? Being 600 or 700 million years old is like being a middle school kid. They're like teens or preteens almost. And kids like to hang out with their friends, especially teenagers. So do teenage stars. Stars can last for billions of years. So if you live for 10 billion years and you're only 7 million years old, you're a teenage star. And that's what these are. And so are the same ones in Berenices' hair over here. Now I want to show you a different kind of cluster. This is what led me to all this. To find it, you draw a line with your mind now from Arcturus, the point of the ice cream cone, towards the hunting dog. That's a star called Coralie. Go halfway between the two and follow, and it lines right up with the end of Berenices' body. So we're going to go to right about here. Let's see if I can nail it. I'm going to say right about there. And let's zoom in and see if we can see this cluster. It should be right in here somewhere. There it is. It's to the right of the star I clicked. It's right here. This is called the Globular Cluster. And globular clusters are different because these are all old stars. These stars are billions of years old. And there's not 200 or 300 stars here. This one is called M3, the same Messier guy. This was the third object he cataloged. And M3 is a globular cluster, and there are 500,000 stars in this cluster. Now, these aren't young stars. They didn't form from nebulas like we talked about with the Beehive Cluster. These have been around for billions of years. And globular clusters halo our galaxy. They're around the, whereas the open clusters are deep inside of it. They form from those pink regions we talked about. All those pink regions were sent to open clusters like the Beehive, whereas these formed when the galaxy formed. And they're very beautiful. 500,000 stars here, and even in a small telescope, you'll see it looks like a little pile of diamonds or a little pile of sugar in the sky or salt. It's very, very pretty. And that's another thing that we're right on the verge of. Just if you're in a dark spot, you can kind of make that out on your own if you know where to look. It looks like a star that's a little fuzzy, perhaps, like one that someone tried to erase with a bad eraser. That's the way I always describe it. If you're in a city, you're not going to see it. You got to be in someplace dark. You might see it with a telescope, but not with just your eyes. All right, so this is all stuff you could see around 10 to 11 tonight. But I'd like to go to just before dawn because there's some interesting things in the dawn sky right now. So we're going to move ahead to tomorrow morning just before the sun comes up. So let's speed up time again. We're looking in the east. That's where we want to look to see the new things coming up. So let's just speed it up. You can see them starting to move here. Let's go a little bit faster. We don't have all night to do this after all. And you see the stars are rising in the east. They cross the sky and set in the west. It's just at the same speed the sun goes across the sky, because after all, the sun's not really moving and neither of the stars. The earth is turning under our feet, and the earth turns at a speed of about 950 miles an hour for us here in Maine. So what we're doing here is watching the earth turn. Well, we're about ready to stop it. We're going to stop it right there. I'm going to stop it for good right there. So this is just before the sun comes up. This is a little bit before 6 o'clock tomorrow morning. Now, do you see this bright path of light through the sky? This is the Milky Way. And that's our galaxy. We live inside the Milky Way. Actually, all these stars over here in the Milky Way, and so are all these stars too. This is like looking into the center. Now, remember that needle galaxy or the Hamburger galaxy, how long and thin they were. Well, we live, remember I said we're about 2/3 the way out, like I showed you the whirlpool. We're inside the galaxy. And this is looking in towards the center. And it looks very much like looking at those two galaxies we just saw, the Hamburger or the needle. And we can't see the whole thing because it goes below our horizon. Outdoors, you can't get rid of the horizon, but here with a program like this, that's a piece of cake. We'll just get rid of the earth and float in open space for a moment. And there you see the whole breadth of the Milky Way. Look at it. It is beautiful. Our horizon goes right through the middle right here, right now, right down through here. So this is the center. That's where we know there's a giant black hole called Sagittarius A right in the center there, equal to maybe at least 1 million, if not 2 million suns. Bad place to go. Don't go there. But it is a beautiful place to look at. And all these dark areas, those are dust clouds. And there's one right in that we can see from Maine. I'm going to bring the ground back up here. And it's a dust cloud that kind of forms a picture that kind of looks like a horse, or so they say. This is the body of the horse with the hind leg here, front legs here and here, one leg's pawing. There's the neck and the head right there. Maybe people who do this spend too much time alone in the dark, because we all see shapes and things when we're tough. It's kind of fun to do that. So that's our galaxy. And we have some star forming regions too. If you look in here, you can see these pink spots. They're the same things. These are places where stars are forming. And as they form, they're going to form those open clusters. This one right here is one of my favorites. It's called the Lagoon Nebula. And this is a giant cloud. This is what those pink ones we saw it like in the whirlpool would look like up close. And we have hundreds of these all scattered through the Milky Way. Slowly, that's going to disappear as stars form. These stars in the middle are young stars that have just formed from this cloud. And if you could hang around for the next 100 million years, this cloud's going to disappear. And in its place will be a bunch of young stars forming a cluster like we saw with the Beehive. This one up here is called the Trifid. This one's a really cool one because let's zoom in on it. You can see the pink. Remember I said it was from hydrogen glowing because of the ultraviolet light stimulates the molecules, makes them glow. The blue light is hydrogen gas too, but that's not being stimulated by the UV light. So the gas isn't glowing, it's just being lit up by nearby stars, like shining a flashlight on something. And when you light it up that way, it has a bluish color to it. And the dark lanes in here are what's called absorption nebulas. Those are clouds of dust, and they're absorbing the light coming from behind it and blocking the light. So there are 3 different kinds of nebulosity here. The red is called an emission nebula because it's emitting light. The blue is a reflection nebula because it's reflecting light. And the dark is an absorption nebula because it's absorbing light. And the Trifid nebula, this one, has all 3 combined. Pretty special place to look in the sky. You can see that tomorrow morning. You'll be in the evening sky by summer. Well, let's move over here. And we've got a couple planetary objects in the sky. The first one you might want to look at, of course, is the moon. The moon's always fun to look at. If you have a pair of binoculars, you'll see it better than you see it with your eyes. So let's just look at it quickly here. Now, the dark areas, which we all clearly see so often, you don't need binoculars to see those. Those are not craters. They're what we call the maria. Each one's a mare or a mare. It's pronounced both ways by different people in different parts of the country, I guess, or the world. And that's an old word which means ocean or sea, because a long time ago, It's argued, some people think that people thought they were oceans or seas on the moon. But most people, if you read the history, the moon was believed to be perfectly smooth. You can't see craters without a telescope. They didn't have telescopes. They thought everything in the heavens had to be perfectly smooth. And so that what they thought those dark spots were was the Earth's oceans reflecting off the perfect smooth crystalline body of the moon. But we now know there's no oceans there, but we know the seas on the moon, the Maria, were liquid once. They were once filled with liquid rock. The moon had actively erupting volcanoes. The lava came out, filled up the low areas, and made these giant lakes of molten lava. Over time, the lava cooled and hardened, and lava hardens as a dark colored rock. And that's what makes the seas we see, hardened lava flows. Now we can see some craters. Here's a crater right here. That crater's name is Copernicus. And this crater here is Kepler. And there are hundreds of craters. The place to look to see craters the best, though, is along the line between day and night on the moon. That's called the terminator line, because there are shadows there. Over here, you don't see many craters, but there are lots of craters through here, but the sun's shining right straight down, and there's no contrast because there's no shadows. You get over here, it's like sunset on the moon. And at sunset, you have a big long shadow, and so do the craters, and that gives you the contrast to make them stand out. That's why Copernicus is standing out so clearly. These lines coming out of the craters are called the ejecta. And that's like, these craters are made when rocks bang into the moon from space. Hits, big explosion, stuff goes flying, and then it falls back down, making the ejecta lines. And the crater is the rock that makes these craters is much smaller than the craters. It's just there's this big explosion and it pushes everything out, making basically like a wave, like you throw a rock in Rangeley Lake, you get ripples going out. Well, on a lake, the ripples go out till they fade away. On the moon, the ripple goes out till there's no more energy, then it just stops and sits there. And that's what makes the rim right there. The other cool thing is sometimes, you can't really see it here, but you see a little mountain right in the middle of some of these craters. Try to look for one that you might see here. They don't all have it, but some of them do. And that's where when the rock hits, it hits so hard, it compresses everything in, and it bounces back, and lots of rocks will fly right up into the sky. Then they fall right straight back down the crater, making a mountain. This one we can't see right now. It's right over here in the shade. It's called Tycho, and that has a mountain that's about a mile high. Turns out it's almost exactly the same height as Mount Katahdin. So Tycho is really easy to see in an earlier phase. And when you see Tycho and you see that little dot in the middle, realize that's the size of Katahdin. Interesting to look at the moon. I like that. We also have 3 planets that you can see in the morning sky right now. The bright one's really easy to see. And to be honest, it's the only one you will see unless you're using a scope. This is Venus. Just to the west of it, you'll see a reddish one, and that's Mars. And just underneath it, a fainter whitish one, which is Saturn. So we have Venus, Mars, and Saturn making a nice little triangle. Now, they all look pretty easy to find, don't they? Venus is easy to find. These two aren't going to be easy to find because the fact is, at 6 o'clock tomorrow morning, the sky is not going to look like this. The sky is going to look like this because the sun's coming up. The sun's just below the horizon here. So you might just pull those two out. If you have a pair of binoculars, you should be able to see both Mars and Saturn. With your eyes, it's questionable whether they'll show up or not. I was out the other morning. I could see Venus just as clear as could be, and I couldn't make those two out. But I didn't have any optics to help me find them better. Now, if you do have a telescope, you might want to check it out. Check out Venus first, because that's the easy one. When you find Venus and you zoom in with a telescope, you're going to find it's going to look like a quarter moon, or what looks like a half a moon, or a half of Venus in this case. Venus goes through phases. Sometimes it's a crescent shape. Sometimes it looks like half. Sometimes it's a little bit more like egg-shaped, and that's called the gibbous phase. That's because Venus is between us and the sun. So you never see a big round full Venus. To do that, you'd have to go between Venus and the sun. And that's not a place you want to go. Venus, it gets hotter as you get close to the sun. Venus is the hottest planet. It's covered with clouds, so you can't see the ground anywhere. You're seeing cloud tops. But we've sent probes down through the clouds to the surface, and we know that day or night, the temperature doesn't change. It's around 900 degrees Fahrenheit. Not a friendly place to visit at all. The air is poisonous, and there's 90 times more air than the Earth, so you'd be crushed almost instantly. It's much better to just look at it from space. It's very pretty. Mars, this low in the sky isn't going to look like very much. It's going to, in your telescope, it's kind of probably going to look like that. Just a little, you'll see a little of that reddish orange color. Now with the program, I can zoom in much closer than you're going to see with your backyard telescope, especially with this low in the sky. And then you might see a few features, some dark areas and light areas. It has 2 moons, Phobos and Deimos. Those are very hard to see. And sometimes you see ice caps and they're not showing up here at all. But right now with Mars that low in the sky, the problem with looking at things when they're low in the sky, even if it was in the middle of the night, it'd be hard to see because you're looking through so much air. When you look straight up, you're looking through 50 miles of air. When you look at something near the horizon, you're looking through about 250 to 300 miles of air, and that distorts all the images. It won't be as crisp as it looks in this program here. And just to note that reddish orange color is because Mars is covered with rust. The rocks and soil have particles of rust all through them, giving it a rusty orange color. And finally, I'm going to finish here with the 3rd planet, which is going to be the most difficult one to see with your telescope, but it's one you definitely want to see. And as we progress into the summer, it's going to be visible this summer. So you'll have some good views coming summertime. And that, of course, is Saturn. But if you do have a telescope, you might just be able to make out the rings. Saturn's rings are made of ice, water ice. Let's get rid of that glare just so we get a good view. Oh, where did it go? Let me pull it back. There it is right there. Get rid of the glare so we get a good view. Now, if you do look at it with the telescope, you're going to have that glare I just had because it's, again, you're low in the atmosphere and it's just before dawn. But I want you to end up with a nice view of Saturn. Saturn is a gas giant planet. There's no ground. You can't land on it. We can't put rovers and drive them around like we're doing on Mars. There's no ground to land on. It's gases and clouds. The rings are made of ice, and it's primarily water ice. So if you took a chunk of Saturn's rings and melted it, you could perhaps drink it. You'd have to work hard to melt it because it's frozen down to about 300 degrees below zero. So it's not going to melt easily, and it would burn you if you touched it, a cold type burn. These rings are like 30,000 miles from the planet to the outer edge. That's a long way, 30,000 miles. But if you measure their thickness from top to bottom, they're about 80 yards thick. 80 yards. That's like less than the length of a football field. So if you could tip Saturn up on edge and bring the rings down onto the 50-yard line of a football field, like the Super Bowl, it'd fit between the goalposts and extend 30,000 miles up into the sky. Wouldn't that be a halftime show, huh? Because since they're 300 degrees below zero, they'll probably instantaneously freeze everyone solid in the stands. You wouldn't really want to do that, but just an interesting thing to think about, I guess. So let's come back to our sky. We started with putting the sun down, so let's finish by bringing the sun up. The sun is going to rise a little north of east, which will be to the left of the E you see there. So if we speed up time or bring the sun up, let's see if it's doing what it's supposed to do. Should be coming here any second now. There we go. There's Mr. Sun, and it was just a little north of east, not very far because we were less than a week away from the equinox, but over time it's going to keep moving towards the north all the way up until the solstice, which is the 21st of June. So that's our tour tonight. I hope you've enjoyed the sky tonight. I'll be glad to take any questions. I'll stop sharing here so I can see you, or I guess you can see me. And if anyone has questions, maybe you can put them in the chat, or you can, I don't know, can they unmute? I'm not sure how if we can get questions that way or not.
Folks can go ahead and raise their hand or submit one through the Q&A at the bottom. Until we get a question. That was amazing, John. Thank you so much for leading us through. I feel a little alarmed about Saturn and lied to my entire life. I didn't realize that it was just gases and clouds and ice.
Well, yeah, Jupiter and Saturn have no ground. You can't land on them or anything. They're clouds and gases and liquids deep inside, but not a liquid with a surface. Like you can't drop a sailboat down and go sailing around or anything like that, you know.
That is just wonderful.
I see there's one quote there. You're welcome, Carrie. Glad you enjoyed it. I hope you all get outside and look at the real sky. We were hoping it would be clear tonight so I could have come to Rangeley. I love going to Rangeley and do a nighttime sky party outside with the real stars. And hopefully maybe sometime this summer we can actually make that happen. I know Amanda said that they have a desire to make that happen, and I'm more than glad to do that. We did it once about a year ago and had it wasn't the perfect sky, but we had a good evening just the same, as I recall.
That will certainly be a goal for this summer.
Any questions from anybody about anything I talked about or didn't talk about? No, I must have put them all to sleep, Amanda.
I doubt that. I think our brains are exploding. Well, thank you all again for joining us this evening. And John, it's been amazing as always.
Well, thank you.
I look forward to programs again in the future.
Well, was that someone speaking up, or was that your background? That was your background. Yeah, well, I am here and I'll be glad to do programs with you anytime. It's always a pleasure, and look forward to finally getting in person at some point and doing it outdoors. Absolutely. But we can do this again too. This is fun. I